In this section, we're looking at linear equations in two variables. I began this set of notes with talking about what is the coordinate plane. And so, a rough drawing of this, you would see basically the four quadrants. What I need you to remember is that the quadrants are laid out in this manner. So this is quadrant 1, that's quadrant. Quadrant 1, that's what this stands for. Quadrant 2, quadrant 3, quadrant 4. And just remember that on this side, both the y and the x are positive. On this side, the x is negative, but the y is positive. That's for quadrant 2. On this side, both are negative. So you'll have a negative x and you'll have a negative y coordinate for this one. The last one, the x will be positive, but the y will be the negative value. And here, as I stated prior, both are positive. Alright. The other thing that you need to note is that this is the origin, and the origin is simply the 0, 0 point. One of the things that they ask you to do in this section is to graph the actual value for a point. And so you simply need to, let me see if I can find you a nice graph paper. I have graph paper. I guess we'll just use the rough graph. Alright, so if I give you a set of points and I say to you, graph the point, okay, and I give you the following, I'll give you 2, 3, I'll give you negative 2, 3, I'll give you 2, let's go with positive 2, negative 3, and then we're going to graph, or both are negative, so negative 2, negative 3. Alright, and so there's your quadrant. Remember, this is the negative x side, this is the positive x side. This is positive y, this is negative y. And if I'm graphing the point 2, 3, I'm going to go over 2, up 3, 1, 2, 3, and you literally are matching the two locations. So there's your point, 2, 3. So this is A. For B, you have negative 2, 3, so there you have to go negative on the x-axis and up 3. So I'm literally going to graph point B, which is negative 2, 3. Okay, and on this side, I am looking at point C, where I have positive 2, negative 3, so that means that I start at the origin over 2, but this time I go down 3, 1, 2, 3, and I'm literally just matching their locations, and that's your point. So this is 2, negative 3 as a point. And lastly, the last point, point D, which is negative 2, down 3, 1, 2, 3, and you're over here. So this is point D, which is negative 2, negative 3. So that's example 1 in your textbook. The next thing that your textbook talks about, or example 2, has to do with looking at equations in two variables, and they're usually written in standard form in the way they're presenting this type of question. So what they're going to ask you is to determine if a coordinate point is an actual solution. So for example, determine if negative 4, 0 is a solution for, say, this particular line. So if I give you a line with an actual value, like negative 2x plus 3y equals 8, all you have to do basically is substitute. So remember, if you were to follow the color coordination, this is your x variable. And let me get you another color here. Let's do orange. This is your other variable. Okay? And so you're substituting in the number as you see. So this becomes negative 2 times negative 4 plus 3 times 0 is equal to 8, and we're trying to assess whether or not it's true. Well, this gives you 8 plus 0 is 8, which is obviously true. So you would say, yes, this is a solution for this particular equation. If you try another one, so let's change the numbers up, and again, remember, all I did was substitute. So I substituted in here, and I substituted in here. Okay, and so this result, negative 2 times negative 4, is what gave me the 8, and the 3 times the 0 gave me the 0, and again, we're testing whether or not this equation, which gives you 8 equals 8, is true. Alright, so let's try another one in this example. And again, in this case, let's use the equation. So we're going to try, given the equation x plus 4y is equal to negative 8, and let's say I gave you the coordinate point negative 2, negative 1. So we're going to try this one, and then we're going to try 4, negative 3, and we'll try that one. And then I'm going to give you point C, which is negative 14, 3 over 2. Hideous numbers that don't like the fractions. Okay, so again, where's your x and where's your y? So we're going to go ahead, here's your y, here's your x respectively, and what you're going to do is you're going to plug it in. So you get negative 2 plus 4 times negative 1 is negative 8. So that gives you minus 2 minus 4 equals negative 8. Well, I got news for you. This value is negative 6. That is not equal to negative 8. So this is a false. That means that this is not a potential solution. Alright, continuing on that example, if I have 4 and negative 3, again, let's use some different colors. So there's your 4, and where's my green mark? Oh, he was blue. There's your negative 3, and we're simply going to substitute this in. So in this case, this will become 4 plus 4 times negative 3 equals 8. Now remember, this 4 is here. This 3 is here. That's where they come from. And a lot of students get confused and they forget that that 4 comes from the original equation. Okay? So you have 4 plus negative 12 is equal to 8. Is that true or false? And in this case, this yields you a false again. Now if this were negative 8 instead, which I think I have here, this actually is true. Okay. And you do the same thing for the negative 14. So negative 14 plus 4 times 3 over 2. Now I'm going to show you how to do this one. This is 4 over 1. Okay? That's how easy this becomes. You literally are going to say negative 14 plus. This is actually 12. 4 times 3 is 12 divided by 2 is 6. Does that give you negative 8? And yes, this is true. Okay? So that's example 2. And that's substituting values to determine if the equation, or if the ordered pair is a solution for the equation. Okay. Example 3. In example 3, it says graph the equation, and the equation in this case is 3x plus 5y equals 15. Now one of the things that I will suggest to you is, if both of these numbers divide into this number evenly, because anything will divide into anything, it's just, well, you get an even number. So the answer is yes. So if I take 15 and I divide it by 3, I get 5. If I take 15 and I divide it by 5, I get 3. Now just for the record, these numbers are interchangeable in any fraction, regardless. So that means that I can use intercepts. So use intercepts. You only need 2 points to graph a line. So in this case, if I set this to 0, plus 5y equals 15, then I get y equals 3. If I do the same thing here, and if I have 3x plus 5 times 0 equal to 15, then x is equal to 5. So my coordinate pairs, respectively, for both of these equations, so for this one, the equation is 0, 3, and for this one, the equation is 5, 0. Okay? So that's example 3, where you're going to graph this, and you literally are going to take a coordinate pair, or a coordinate plane, using the 2 points that I gave you. Here's 1, 2, 3, 4, 5. That's the 5, 0. And then we're going to do 1, 2, 3, and that's your coordinate plane value, or y-intercept. So this is, by the way, the y-intercept. The way I showed you, if you remember, is that that's sitting on, the number is sitting on the y, so it's a y-intercept. And here, this is your x-intercept. Okay, and so now you just need to connect your dots. If you connect your dots, there you are. Alright, and there's your line. So that's example 3. Okay, example 4. In example 4, it also says graph. And for this it says y equals 1/2 x minus 2. And so what I would recommend, anytime they ask you to graph, if they don't provide you a table, create one. You can always start with x is 0. With x is 0, this is always your y-intercept. So we know that we have 0, negative 2. And that's a point to start with. What you can also do is remember that your slope, this is the change in y over the change in x. So if this is 1 over 2, that means that I'm going to go plus 1 on the y and plus 2 on the x. So this is your slope. Right? Your final answer for this will become negative 1, 2, which means that if I'm graphing and I'm starting at 0, negative 2, I'm going, according to this, over 2 and down 1. So this should be your next point. I'm also looking at this as up 1 over 2. So I can do it either way. I could do the counting method, as in a change of 1 in the y, so I go up 1 because it's positive, and to the right 2 spaces because that's also positive. That's all you need are 2 points, and you draw your line. Alright. If I look at example 5, in example 5, we're looking at x and y intercepts again. So if the question stem says given 2x plus 4y equals 8, and they want you to find the x and y intercepts, you're going to do exactly what we did prior. You start with setting x to 0, leaving you 4y equals 8, and therefore y equals 2. If you have 2x plus 4 times 0 equals 8, therefore y equals 4. I'm sorry, x equals 4. My mistake. Right? Because that's what we're solving for. So if x equals 4 and I have y is 2, that gives me the 2 intercept points. So this is 0, 2, and this is 4, 0. That's how simple that is. And now I could just graph using a coordinate plane. Right? There's your coordinate plane. If I'm doing 0, 2, when x is 0, y is 2, so I'm here. That's the point 0, 2. This is your y-intercept again. And here's 1, 2, 3, 4. You're over here now. This is the point 4 comma 0, and this is your x-intercept. I'm just going to put int. And then connect the points, and there's your line. Just remember, they continue. Okay, example 6. In example 6, they're going to tell you given y equals 1/4 x. If you notice, there is no y-intercept, so there's literally, in theory, a plus 0 there. Since there is no intercept, that means that this goes through the origin. So if I'm graphing this, I'm going to start at 0, 0. Because when x is 0, y is 0 also. According to the slope, I'm going to go up 1, and because it's a positive 4, I'm going to go 1, 2, 3, 4. And this is my point. So the next point that you see here is actually the point 4 comma 1. If you notice, it's the reverse of the slope, right? And now just connect your 2 points. Just remember there's points after that origin and above that origin. Okay? Simply connect the dots. Alright, example 7. It's the same thing in word problems. So if I have an equation that says y equals 65,000 minus 13,000x as a word problem, using x-intercepts, I literally can solve. So I know that when x is equal to 0, that y is equal to 65,000. Right? And according to this slope, this is going up 13,000 on the y and 1 on the x, the change in x. What you can also consider is that you can also reset this equation where 0 is equal to 65,000 minus 13,000 x, and now we need to solve for x. So the first thing I'm going to do here is I'm going to subtract 65,000 on both sides. What ends up happening is this will cancel on this side. And now I have a negative 65,000 on this side of the equal to sign is equal to negative 13,000 x. Remember, the x is what we're solving for. To solve for x, I need to divide by negative 13,000 on both sides. So now this cancels. And you're left with your x on the side equal to the negatives cancel. And I believe this is 5. So now you have your 2 intercepts. You have an intercept in 0, 65,000. And you have an intercept of 5, 0. Okay? So that's a word problem interpreting corporate depreciating assets. Now the horizontal and vertical lines, let's talk about that. I'll talk about them together. So these are examples 8 and 9 respectively. So if I begin by talking about the vertical line, just keep this in mind, and I've always said this in class. This is your y-axis, it's a vertical axis. The horizontal axis is the x, right? But when it comes to a vertical line, the value is typically x equals something. So let's say x equals 6. That means that I'm going to go 1, 2, 3, 4, 5, 6, and then I begin to draw my line vertically. Because x is 6 here, it's 6 here, it's 6 throughout this entire line. It's not a point, it's a line. Because it's a line, you literally draw a line at x equals 6. For example 9, you have the horizontal axis. Now, ironically enough, the vertical axis is the y-axis, but if I ever have a value that says basically y equals something. Say for example y equals 3. I'm literally going to go up 1, 2, 3 because it's positive, and then just draw my line across. Again, it's a line, not a point. So interestingly enough, they are the opposite of their axis. So if I have an x equals, it's the opposite of their axis. The axis is horizontal, but the value that you obtain will be a vertical line. For the horizontal line, actually it's a y equals situation. If y equals a value, then I have to have a horizontal line for a response. Alright, it's no different if you were to do a fraction or what have you, it's still the same. Okay, and that is section 2.1. I hope this is helpful.